Okay, so as you know, HPC is strategic for the economical growth and industry competitiveness. So EXDCI is trying to fit into that idea, and it's also, we understand that we need a critical mass, we need a coherent effort to achieve exascale. So somewhere EXDCI is trying to fit into this spirit. Just to report a study we did before is for the money that is invested in HPC is actually quite useful. The IDC studies we had with innovation coming from or that use HPC to become basically says for $1 invested, it allowed to generate $850 in business. With a benefit of 50 for this 850. So this is actually quite efficient and quite necessary to have a good HPC ecosystem if we want to innovate. The HPC challenges, you have heard a lot of those, but we have to consider parallelism, fault tolerance, energy efficiency, heterogeneity, data management and exploration. This has been said already. But somewhere another view is you can also think about exaflop project is not only to get one machine of a kind, it's also to get a petaflop in a box, which will help more people, more companies. So somewhere you can also see the exaflop as going to low power HPC. And of course, this is in the context of technological disruptions with the new photonics technology, new memories, many core CPUs, etc. So we have a fast and moving landscape that requires everybody to work together to achieve something. And we have laws that are reaching limits. This is usually the laws that are helping us, like Moore's law, Desnard's law, Cridor's law. And we have laws that remain, like the cost of foundries, the Amdahl's law and Gustafson's law. And because of these changes, this moving landscape, we have to change a lot of things from the algorithm to the hardware we have to build to achieve exascale. The design has to be done with many constraints. So, of course, energy is a major one, and that's why we are going to massively parallel multi-core. That's why you may need accelerators. And there is a memory wall, and especially the data explosion that has to be considered in the design of the machine. On the right, I just put a small example. So this is the climate Earth system modeling data projection for the next years. And you see that between 2013 and 2020, they will get an increase of 6,000 times of the amount of data produced every month. So this is huge, but all this can't really be achieved if we don't take into account an economical constraints. That means if the code don't scale well, which would be the case from the code we have now, we won't get an efficiency that gives the time to solution and economical benefit. So EXDCI is an interdisciplinary CSI. So we have to consider many different things, from tool and programming models, massively parallel architecture, data-centric approaches, big data kind of technology, ultra-scalable algorithms, and efficient exascale applications. So somewhere, EXDCI has to consider all those issues to build a roadmap that makes sense. So there is two main scientific actions. So that was said before, the SRA. And here I have listed the current working groups, so architecture, balance IO, etc. And there is, on the other side, the application side, the praise scientific cases. And in here you have weather, astrophysics, etc., the HPC, usual bread and butter. EXDCI is not the only CSA, so we have to synchronize with the other CSAs called Eurolab for HPC, and this is the main topics where we have to find to synchronize properly. So on the road mapping, on the training, and on the managing, on the innovation. I have look at the FETHPC project, and just to give you an idea, so EXDCI will have to follow what's happening in the HPC projects. And here I have make from the summary, so it has to be carefully looked at. But you see there is basically two main topics addressed by many projects: programming environments and energy, that's Henry. And if you look at the big data, there is only two looking at the big data. So somewhere we have a lot of effort made in programming model, and this is actually a very important thing. Most of the projects are considering energy, but big data and data management are still not very addressed in those projects. But one of the tasks in EXDCI will be to survey what's happening in this project and to make sure that the roadmap we are building take into account the advance of those projects. The other big things that, for EXDCI is a BDEC, so the Big Data and Extreme Cell Computing workshop series that was taken care of by ESI for the EU part in the past, and now EXDCI will, with the people that were involved in that, as Sergey said, will continue that. And this is an initiative between almost everybody: Asia, Japan, Europe, USA, where we discuss and see what is what would be the plan for developing the next generation open source software for scientific performance computing. And there will be some report coming out of this initiative soon, normally. So, in a nutshell, if I take EXDCI, we want to increase the ecosystem synergies. We want to take the economical dimension into account. We want a collaboration between the different CSAs. And also takes into account the fact that Exascale Road is also a worldwide initiative, so it's not contained only for EU. So we need to understand what the others are making and how we can collaborate in a positive way. We need to care about what's happening in the Center of Excellence in the FETHPC projects, so we build a roadmap that take into account their progress. And it's interdisciplinary, so we need to care about applications, we need to care about technologies, and we need to care about programming softwares, etc. And to conclude my presentation, EXDCI somewhere address at least part of all the challenges for Europe, which is a co-design of HPC system and applications, exascale ecosystem development, and transition to exascale computing, with these different phases of the problem. Thank you.